If you're waiting until the end of the day to find out why your factory lost money, you are already too late.
Welcome to Easy Business Automation.
We're the show that helps business owners demystify AI.
And use automation to solve real problems, without needing to become tech people.
Today, we're getting into the world of physical operations, specifically manufacturing and factories.
We're looking at AI precision and how you can scale your efficiency.
We've been looking at some amazing research showing how machine learning is finally bringing real predictive power to the shop floor.
That's right. We're pulling from studies on things like deep learning models and pairing that with real-world cost-benefit numbers from factory projects.
And our goal is simple.
By the end of this, you'll know exactly how AI can turn your old, backward-looking factory metrics into reliable, forward-looking predictions.
And we'll give you 3 simple, low-risk actions you can take this month to start cutting waste and boosting your consistency. So let's start with the big one, the core pain point that almost every manufacturer deals with.
OEE.
Overall equipment effectiveness.
It's the standard for measuring your production performance. And it's a great concept, really. It combines time, speed, and quality all into one score to show you where you're losing money.
But there's a fundamental flaw in how most businesses, especially smaller ones, actually use it.
A huge flaw. They do it after the fact.
Right.
The calculation is traditionally what we call a posteriori, a fancy way of saying after the event. The shift ends, someone tallies the data, and the manager sees it the next morning.
So they're basically diagnosing the problem after the patient has already gone home.
That's a perfect way to put it. You find out about the machine breakdown or the bad batch of materials when it's way too late to do anything about it.
You've already lost the money, the labor, the materials, the energy. It's just gone.
And that's the missed opportunity. This is where AI just completely changes the game. It transforms OEE from a history report into an active, forward-looking decision tool.
So instead of asking what went wrong yesterday, you're asking,
what's our effectiveness likely to be in the next 4 hours? It shifts everything from analysis to intervention.
You can actually get ahead of the problem.
Exactly. And we found this great real-world scenario, an automotive company that makes custom cable and wiring harnesses.
Oh, that's a really complex process. So many places for things to go wrong.
Thousands of precise cuts, tiny connections. Their cutting department had efficiency that was just all over the place.
So what did they do?
They brought in a machine learning system to predict the OEE score for that department hours in advance.
Okay, so what does that actually look like for the manager on the floor? How does that change their day?
Well, think about it. Before, they'd only know they had a quality problem when the bin of rejected parts showed up at the end of the day. Now, the system sends an alert. It says something like, based on the materials you just loaded, we predict your quality score will drop below 92% in the next 2 hours.
Wow. So it gives them a 2-hour window to act.
It completely changes their workflow. The manager can now go and proactively check the inputs, the machine settings, the material batch, even the operator setup process, and fix the potential problem before it happens.
Before the scrap starts piling up.
It's moving from reactive firefighting to proactive prevention.
That makes so much sense. Okay, before we go deeper, let's quickly explain the 2 key concepts here. First, OEE itself.
Right. OEE, overall equipment effectiveness. It's the single score for how efficient your machine is. A perfect 100% score means you're running as fast as possible for all your scheduled time with 0 defects.
And it's made up of 3 factors, right? Availability, performance, and quality.
That's it. Availability is about time. Was the machine running when it was supposed to? Performance is about speed. Was it running as fast as it could? And quality is the output. Did you make good parts or scrap?
And when that score drops, it's because of what are called the 6 big losses.
Exactly. And this is what AI helps you target. You've got breakdown losses, so unplanned failures, reduced speed losses, like running slow because of bad material, and quality defect losses, which is just scrap.
Okay, so that's OEE. Now for the AI side of it, predictive automation, how does it actually create that forecast?
So we're talking about algorithms like deep learning that study just massive amounts of your historical production data.
And it's not just looking at when machines failed, I assume.
Oh, it's so much more. It's looking at every variable you can imagine, the material batch ID, the factory temperature, which operator did the setup, the age of the tooling, everything.
So why do you need something so powerful like deep learning for that? Why
Yeah.
not a simpler statistical model?
That is a critical question. It's because factory environments are, well, they're chaotic.
Right.
Simple models assume clean, linear relationships. If A happens, then B happens. But on a factory floor, the relationship between, say, tool temperature and product quality is almost never a straight line.
It's messy. It's non-obvious data.
Precisely. Deep learning models are built to find those complex, nonlinear patterns in the mess. They can see that, operator A using material X on a Tuesday when it's over 75 degrees always leads to a 5% quality drop.
A pattern no human would ever spot.
Never. And that ability to find those hidden connections is what creates a reliable forecast hours ahead of time. It gives you that warning so you can actually intervene.
Okay, let's make this really practical now. Let's unpack this for 3 different roles in a small manufacturing business. We'll start with the operations and production team.
So the before picture for them is pure chaos. It's firefighting, they're waiting for a machine to break down, and then it's a mad scramble.
That's the unplanned downtime we were talking about. So how does that change in the after scenario?
They shift to predictive maintenance. AI tools are always monitoring the machine's condition, using data from vibration, temperature, and internal error codes.
Now, hold on. Does that mean a small business has to go out and spend $50,000 on new sensors just to get started? Because that sounds like a huge barrier.
It can be, and that's a great point. But you don't always need a massive overhaul. Many modern machines already log tons of valuable data. The first step is often just connecting to that existing data stream.
So you're leveraging what you already own.
You are. And the system learns the pre-failure signals. It spots the signs of trouble early, so maintenance can fix it during a planned shutdown, not in the middle of a critical production run.
That's a huge win for consistency. Okay, next up, the factory floor workers. People hear automation, and they immediately worry about their jobs.
And that's understandable. But in reality, it's about job reallocation, not replacement. Before, workers were often stuck doing really monotonous, repetitive tasks.
Like manual inspection or simple assembly.
Exactly. Things that humans, frankly, aren't great at doing consistently for 8 hours a day. It leads to errors and quality problems.
So what are the tools that are changing this for a smaller shop?
2 big things: collaborative robots, or cobots, and advanced vision systems. Cobots are smaller robots designed to work safely right next to people. They're perfect for those specialized, repetitive motions.
Like the ultimate consistent employee.
It is. A cobot doesn't replace the assembler. It replaces the assembler's hand for one tedious task repeated 5,000 times a day. And vision systems, basically smart cameras, check for defects with an accuracy a human just can't match over a full shift.
Right, especially for tiny, hard-to-see flaws.
So the outcome is that your people are moved to more valuable work-like quality supervision or complex problem solving, while the business gets a massive boost in predictability and reliability.
Okay, finally, let's talk about the owner or the leadership team. For them, it always comes down to the money. How do you justify that big initial investment?
The key is to be smart and adopt a semi-autonomous strategy.
Okay, what does that mean?
It means you don't aim for the super expensive lights-out factory that runs itself. That's a fantasy for most businesses.
So what does semi-autonomous look like in practice?
It means you design the system to run smoothly under normal conditions, but you also train it to be an amazing watchdog. It knows when something is just a little bit off.
A part is misaligned, a tool is getting dull.
Exactly. And when it spots that, it doesn't try to solve the complex problem itself. It safely stops and alerts the human operator for help.
So you automate the predictable 80% of the job and keep a human in the loop for the complex 20%.
And that avoids the insane development cost of trying to automate every single possible error. You get almost all of the benefit for a fraction of the cost, which maximizes your ROI immediately.
And we have some amazing data on that financial return from a study on automating modular construction.
Yeah, that's a tough industry to automate, but the results were incredible. By automating just the panel assembly stage, they saw a 37% reduction in cycle time.
37% faster production, that's huge. But did it pay for itself?
It did. When they factored in the long-term savings on labor, energy, and reduced errors over 10 years, the project had a benefit-cost ratio of 2.61.
So explain that number. A ratio of 2.61 means what?
It means for every single dollar they invested in that automation, they got back $2.61 in value.
Wow.
It proves that smart automation isn't an expense, it's an investment with a predictable, measurable financial return.
That's the kind of proof leadership needs to see. Okay, let's wrap this up and give our listeners clear actions they can take.
We've got 3 low-risk steps you can start on this month.
Okay, action number 1. Calculate your OEE. Get your baseline.
You have to know where you're starting from. Start tracking your OEE score. This will immediately show you where your biggest production leaks are. Is it scrap? Is it downtime? That tells you where to focus first for the fastest return.
Right. Action number 2. Start with visibility, not prediction.
Exactly. Before you try to predict the future, you need to see the present clearly. Find simple tools that track your process and machine conditions in real time. Good, clean data is the foundation for everything that comes next.
And finally, a tangible pilot project. Action number 3.
Pilot a low-cost cobot project. Find the single most boring, repetitive, safe task you have in your secondary operations labeling, simple assembly, and investigate using a simple cobot or vision system for just that one task.
And keep it semi-autonomous, right?
Absolutely. Keep the human in the loop. This keeps the cost and the risk way down, and it lets you prove the ROI to your team very quickly. Try to get it done in 30 days.
This all brings us back to that core idea of using prediction to get rid of chaos. So if the goal of AI isn't to replace humans, but to give them a digital assistant that helps eliminate all those costly, unpredictable errors in manufacturing, what operational chaos could you make completely predictable by this time next month?